Hello everybody, welcome to the Python course. Today we will do module 3 of the Python course. In the previous lecture we have done module 2, that was Python data types and variables. In this part we will cover operators and control statements. This module has been divided into two parts. In the first part we will deal with operators, arithmetic operators, assignment operator, logical operator, relation or comparison operator, and in the second part we will deal with the control statements, that is if else statement, nested if else, for loops, while loops, break statement, continue, pass, and then in the later part of this section we will do some programming associated with these topics. Okay, so let's start with the course. Okay, so in this lecture we will cover what is an operator and operands, and we will see what are the different types of operators we have in Python language. First we gonna see what is arithmetic operator, then assignment operator, relation or comparison operator, and how we can do the carry out the working, and then we'll see the logical and bitwise. In the end we will see how the precedence of operators works. So what are operators? Operators are special symbols that help in carrying out an assignment operation or arithmetic or logical computation. Right? Now you in the screen you can see that it is there 2 plus 3. So plus is a operator and 2 and 3 are the operands. So value that the operator operates on is called an operand. Now in this example 2 and 3 are known as operands and plus is a operator, that is known as addition operator. And what are arithmetic operators? So arithmetic operators are the operators which are used to perform mathematical operations between two operands. For example, we have created two variables named a and b with values 10 and 5 respectively. Now in order to add these two variables we need some kind of a operator that is denoted by a plus symbol, and the operation which it does is addition. So that's why it is known as arithmetic operator, because it performs some mathematical operation. Similarly, we have another operation, that is subtraction, and we carry out this operation by a minus symbol. So if we wanted to subtract two variables, then we could simply write a minus b. Similarly, if we wanted to perform multiplication operation, so the symbol is star, and we can perform easily a star b, then carry out the results. Likewise, we have a division also, which gives the division between these two symbols, and result is carried out in the format of floating point values. So this thing we need to note and remember: division operation always results the value in floating point value. Similarly, we have a remainder operation followed by a modulo symbol, right, or percentage as we call it in general terms. So a modulo b, right, it gives us the remainder. So for example, in a we have a value as 10 and in b we has a value of 2. So a modulo b, that is a modulo 2, will give us the remainder as 0. Similarly, if we wanted to find out the power, that is known as exponent, and the symbol is double star. So a star star b, we get the power, that a raised to power b or 10 raised to power 5, we get 100,000, right? Okay, so let's practice this operations using Jupyter Notebook. So in my screen I have already launched Anaconda Navigator, which I have already taught you in the previous lectures, right? Now we can click on Jupyter Notebook to launch a new Jupyter Notebook. Okay, now the Jupyter notebook has been launched. So now I traverse to my documents, then GitHub projects, then Python trainings, and go to Trunic, right? I create a new notebook by named as operators, and this is module 3. Okay, right? So let's perform these operations. So now I have created a variable named a with the value as 10 and b with the value as 5. So if I want to print a and b, so a gets the value as 10 and b gets the value as 5. Now I wanted to perform the addition operation by using the plus operator. So if I do a plus b, it will give us the result as 15. Similarly, if I wanted to perform the subtraction operation, it will give us a minus b, that is 5. Likewise, we could also have a multiplication operation. It will give us a into b, that is 50. Similarly, we have a division operation. A divided by b, it is 2.0, right? Now, this is known as normal division. Another case of division, if we wanted to get rid of the floating point value and instead we wanted to get the integer value in case of division, right? So that can be operated using float division. So this operation is known as float division. Now the value in the division is floating point value, but the resulting value in the float division is an integer value. So this is the basic difference between a division and a float division. Then we come across the exponent, a raised to power b, it is 100,000, right? So these are the basic operations which we did using the using the different operators. Okay. Now in this slide we have the hierarchy of arithmetic operators. In the right hand of the screen you could see a expression a equal to 7 minus 2 multiplied by 27 divided by 3 raised to power 2 plus 4. So this expression could be evaluated as 7 minus 2 multiplied by, in bracket, 27 divided by 3 raised to power 2 plus 4. So we now wanted to know how this expression is evaluated. In normal mathematics terms, we have a BODMAS rule. But in terms of your programming, so we have some decreasing order of precedence. So which operation would be carried out first, then after that which operation should be carried out. Likewise, in this slide you can see that the first operation will be carried out whatever the value is in the parenthesis. For example, in this part you can see 27 divided by 3 raised to power 2 is in parenthesis. So this expression would be evaluated first, right? So you divide 27 divided by 3, comes out to be 9 3s are 27, 9. Sorry. So we first get the parenthesis, right? So this expression could be evaluated, but you cannot perform the division, right? But we need to follow the exponent, right? The normal tendency is that we generally follow the division, but it is not, right? So you need to first evaluate the exponent value, right? That is 3 raised to power 2. So instead of doing 27 divided by 3, so we first calculate 3 raised to power 2, that is 9. So now it comes 27 divided by 9 because this expression has been evaluated. After that, we look for what expression needs to be evaluated next, what operation, that is division. Now we will do 27 divided by 9, that comes out to be 3. Now this whole expression has been evaluated, whichever was in bracket, right? Now we are left with 7 minus 2 into 3 plus 4. Now out of the multiplication and minus and subtraction, addition and subtraction, we will carry out multiplication operation. So we will carry out 7 minus 2 into 3, that is 6, plus 4, and now rest addition and subtraction would carry out, and 7 minus 6 plus 4 gives out to 5.0. Why this 5.0 has come? Because there was a division operation, and the value inside the division or the resulting value of the division is always a floating point value. So that's why we get a decimal point here, right? Now the next topic is that assignment operators. So what are assignment operators? They are used to assign values to the variables. This we have seen earlier also when we were doing the data types and the variables part. We assign the variable some value by using a assignment operator. For example, a has been assigned a value of 10 by using the assignment operator. Its symbol is equal to, right? And we have another operation in which adds the right operand to the left operand and stores the result on the left side of the operand, right? For example, we want to do a equal to a plus b. We wanted to first calculate a plus b, and then we wanted to replace the value of a with a plus b. So this operation we are doing it by using a equal to a plus b. The similar operation we could do by using a plus equal to b. This operation a equal to a plus b or a plus equal to b is same. Let's see this operation practically. For example, now I'll check what is the value inside the a. Inside a we have 10 value. For example, this is the normal operation which I wanted to do. A equal to a plus 10, a plus 1. So now what is the value of a? A is 11, right? So now again I would check what is the value of a. Suppose I write like this for the better understanding. First I'll print a, then I'll do a plus 1, then again I will do print a. This looks far better than what we were doing earlier. Oh sorry, a plus a, my bad. Okay, first the value was a was 1, then I incremented the value of a with 1. Now the new value of a has become 2. This works perfectly fine. Instead of doing this, what I can do is I can write like this, right? Now one thing to remember, the new value of a has become 2. So now it is 2, then it will print 3, right? Okay, or to simplify the process I can do like this also, right? Now the value of a is 1, I printed a, it comes 1, then I incremented the value by 1, then the new value of a becomes 2, right? Either you do like this or you do like this, a equal to a plus 1. This seems no difference and it is same, right? Similarly, if we wanted to subtract a equal to a minus b, then we could have, instead of replacing we could simply replace the plus sign by a minus sign, minus operator. So this we can do it, right? Similarly, in place of a plus 1, I could do like this, a minus equal to 1. Now first the value of a was 1, I decremented the value of a by 1, then the new value has become 0. Similarly, if I wanted to multiply that value, that can be also be done by using a star and equal to operator, right? That is its symbol. Just replace the value of minus by equal to, star. Suppose I wanted to get the value a multiplied by 5, right? First the value was a was 1, then I multiplied the value of a by 5, the resultant is 5. Similarly, I could also divide the value and stores the value in a itself, right? Okay, so this is how assignment operators are done. Now in the second part we will study about relation or comparison operators. Okay. So relation operators used to find, right, whether the particular value is greater than or less than or equal to or greater than or equal to, and the comparison operator is used to simply check whether the particular value is equal to the another variable or not, right. So let's see this thing. We create two variables x and y with values 5 and 7 respectively. Here we wanted to check whether x is greater than or x is less than 5 or not. So what symbol we can use it? Strictly less than, right. So this is a symbol which is shown in this figure, which we can use it to check whether x is strictly less than y or not, and the resultant would be a boolean value. It would be either a true value or a false value. Similarly, we could also check whether the value is less than or equal to, that we can check by less than or equal to operation, and the resultant would be true or false. Similarly, greater than and greater than or equal to, right. Then the last operation is comparison operator, which is equal to. In this we need to check whether it is equal to or not, right, whether x is equal to y or not, and it will return us boolean value, that is true or false. And similarly the opposite of equal to is not equal to, right, so it will return us true or false. Let's practice this. Okay, so we take two variables x and y equal to 5 and 7, right. I want you to check whether x is greater than y or not, false. I want you to check whether x is less than y or not, it will return us true. X is greater than or equal to y, it will return false. Similarly, x less than or equal to y, it will return true. And we want to check whether x is equal to y or not, false. Remember, x equal to y and x equal to y, these are two different operators, right. This is assignment operator, we are assigning the value of y to x. Here we are comparing the value of x with y, right. So here in this case we could also check like this, whether x is equal to 5 or not, right, or x is equal to 2 or 1 or not, right. So when you do like this, so it means we are assigning the value 1 to x, and here we are comparing it. So don't get confused between assignment operator and comparison operator, right. Similarly we have not equal to, right. So it will return us true and false value based on the condition which holds true or false respectively. Okay, now the next part is logical operators. When operands are conditional statements and returns boolean value, that is true and false. This we already discussed and had understood. Now in Python, logical operators are designed to work with scalars or boolean values, right. So for that we have operation called logical or and the symbol is or, that is or, right. For example, we have expression here, that is x is greater than y or x is less than y, right. So we wanted to evaluate this condition or expression, and the resultant of this expression would be a boolean value, that is true or false. But how does this logical or operation works out? So to understand it, we need to draw the truth table of the or table, right. So let's draw the truth table of or, right. We have a x, we have a y, and then we have a result, right. The result is a boolean expression, that is true or false, right. So in the x we have some expression which will return us true or false value. Suppose x has given us the value as true, y has also given us the value as true, and we are taking the or x or y, and the result is also true, right? So this is our normal OR table, that if one of the conditions satisfied, then result is also true. If one of the condition is false and another is true, then also the result is true. The opposite is also true, right? But if both the conditions are false, then we have result as false. So this is our truth table, right? Right. Okay. Now what we'll do is we'll have expression that is x and we have y as 7. Okay. So now I will check what is x greater than y, that is false. Then or x equal to 6, right? So I wanted to check this. So this seems our x, this one, and this seems our y, that is this one. Now we wanted to evaluate whether this expression results as false or true. If it is true and this expression is also true, the resultant will be true, right? So let us compute what will happen. So this expression gives us the false value. Now let us check why it has given us the false value. So first we will evaluate x greater than y. So it is false. Now we know that this is false, right? Then we'll check x equal to 6. This is also false. Now you can see that in the truth table we are here in this condition. Both the expression yield us false value. This is also false and y expression is also false. So the resultant of this expression doing a OR operation will also give us the false, right? Okay. Now what I'll do is I change the expression to x less than y. Then I wanted to check. Now the expression has changed to true. Now let us see how does it happen. We haven't changed this expression. This is already false. We have changed x is less than y. So this is true. So true and false will give us true. So this is our resulting operation, right? Now let us check what will happen if we wanted to evaluate this kind of condition. So this is false and x is equal to 5. Okay. Now this condition is false. X is greater than y, it's false. And if I wanted to check x is equal to 5, this is true. So first condition is false and second condition is true. The resultant is also true, right? Similarly, if x is greater than y, this is true, and x is equal to 5, this is also true. Now you can see that both the conditions are true, and then we get a true in the result. So this is our logical OR operation works between these two operations, right? Then the next logical operator we have is AND. Likewise, we have a OR truth table. Similarly, we have a AND truth table also. To understand AND better, logical AND better, we need to first understand the truth table of AND. Let us make the truth table of AND. Here we have x and y and we have the result. If both the conditions are true, then the result is also true. If the first condition is true and second is false, then we have a false operation. but in the OR we have a true. So OR works if one of the condition is true, we get a true, but in case of AND we need both the conditions to be true, then and only then we get a true, otherwise not. So there is only one condition which satisfies the AND truth table, that is, it should have both the conditions evaluated to true, then and only then it will result in true. So let us check. We have expression x equal to x greater than y, that is false. Okay, and x equal to 10, right? So x equal to 10 is also false. Now the resultant of this operation would be always false because both the operations are false, right? Similarly, if I change it to x equal to 5, this is also false, right? Because x equal to 5 is true. So this expression is evaluated, right? This is false and this is true. The resultant is false. Then we interchange it, right? Then also the expression holds true, right? Either of one of the, if one of the operation is false, we get a false, right? Now I make both the expression as true, the resultant will be true. Similarly, we have evaluated the first condition also. This is how truth and truth table or the logical AND operation works, right? Similarly, we have the logical NOT. So what it does, it carries out the reverse of the operation. If the particular expression yield us true value, it will give us the false, right? For example, here in this evaluation of the expression, we are getting a true value. If I place not in front of this expression, so it value will change out to be false, right? So this is how we can have this logical operators, that is OR, and NOT. Now we come up with the bitwise operators. They are used when operands are integers, right? So integers are basically treated as string of binary digits. They operates bit by bit, right? They can also be operate on conditional statements which compare scalar values on arrays. So normally we have two kinds of bitwise operators, that is bitwise OR and bitwise AND. For example, we have created two variables x and y with values 5 and 7 respectively. X is 5, y is 7. Now we change the value of x and y in the binary code. So binary code for 5 is 00000101. So how this expression is evaluated, how this binary code has been formed, right? At this outermost number, that is 1, this is being evaluated as 2 raised to power 0. This is expressed as 2 raised to power 1. This is 2 raised to power 2 and this is 2 raised to power 3. If you wanted to make 5, this bit has been changed to 1, it should be on, and this bit has to be changed on, because this is 2 raised to power 2, that is 4, and this is 2 raised to power 1, that is 1, sorry, 2 raised to power 0, that is 1, that 4 plus 1 is equal to 5, right? Similarly, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 4 plus 2, 6 plus 1, 7, right? Okay, so in bitwise OR, operator copies a bit to the result if it exists in the either operator, right? And it copies the bit to the result if it exists in both the operands. So the similar OR operation works on the same logic. If one of the bit is true, it will execute as true. If both the bits are true, then and only then AND operator will work, right? It will result us in true value, else not. Similarly, if I do a bitwise OR on integers x or y, it will compare the bitwise operation, that is 0 is odd with the binary code for 7 and it will result in 0, because we have false and false, it will give us false. Here 0 is treated as false, 1 is treated as true. Similarly, if I check this is true, true and true will yield us true, right? Similarly, 0 false and true will yield us true if we are doing the OR operation, right? So this takes place in the bitwise, right? Every bit is being ORed with the other variable bit, right? We are comparing the bits or ORing the bits of one variable to another variable, right? So bitwise OR can also operate on conditional statements. Likewise, we have already seen in case of logical bitwise logical OR and logical and logical NOT, right? Okay. Now we'll check the precedence of operators. So this is the decreasing order of precedence of the operation. We have already seen first the parenthesis will work, then exponent, then division, multiplication, addition and subtraction, and in the end we have the bitwise AND. Similarly, after that we have bitwise OR, then relation and comparison operators, then we have in the end logical NOT, logical AND or logical OR, right? Okay, so now in this part we have covered the operators and operands, arithmetic operations, assignment operators, relation, logical and bitwise, right? So now the module 3 of the first part has been completed. Okay, so now in the next lecture we will begin with the next part of the next part, that is control statements. Okay, thank you guys for watching it.